Hello, welcome to this video on the convex mirror. In this video we will discuss the basics of the convex mirror. So the convex mirror is shaped like this, and similar to what we discussed about the concave mirror, you have to imagine that this mirror is part of a circle or a sphere. So I'm drawing in a circle here, and we know that every circle has a center, and that's this point here, C. So just as for the concave mirror, C is known as the center of curvature. Now, again, as with the concave mirror, there is this point here, capital F, which is known as the focal point. And point O once again represents the center of the mirror. Now if C is the center of the circle or sphere, then of course the distance from the circumference to that center, well, that's just the radius. So this is R, capital R, the radius. Just like we discussed for the concave mirror. And again, the distance from the center of the mirror to the focal point, we call that the focal length. Little f. And just as for the concave mirror, the relationship between R and F is simply that R, the radius, is equal to 2 times the focal length. So there is a video where we go through the proof of this for the concave mirror, and you should watch that if you haven't already. So let us look at how the convex mirror affects light rays. Let me just mention first that this line here that passes through the center of the mirror, this is again known as the optical axis. So let us look at light rays that arrive at the mirror parallel to the optical axis. So let me draw such a light ray. It turns out that such a light ray will be reflected by the mirror in the following manner. So what I have to draw first here is a dashed line to help me draw what I'm about to draw from this point to the focal point. The ray that arrives at the mirror at this point will reflect along this direction of the dashed line that I've drawn here. So it will reflect something like this. Let's draw another example of this, but below the optical axis. Again, if I draw a light ray that hits the mirror, traveling parallel to the optical axis. Once again, I draw this dashed line from here to the focal point, and the reflected light ray reflects off in the same direction as this dashed line that I've drawn here. So like this. Okay, so this is one of the rules of how a convex mirror affects light rays that arrive parallel to the optical axis. Next, let us look at light rays that are directed towards the focal point. So let me draw what I mean by that. Again, let me draw a dashed line to the focal point. So let's imagine we have a light ray that comes in like this. Okay, so you can see if I were to extend this line, it would continue along this dashed line to F here. Such a light ray reflects off the mirror and travels parallel to the optical axis. So it travels away from the convex mirror parallel to the optical axis. Let's draw another example of this, but above the optical axis. So again, we draw in a dashed line. And so if we have a light ray that comes in and hits the mirror like this, it will reflect off the mirror and travel away from it parallel to the optical axis. The last thing you need to know about how the convex mirror affects light rays is light rays that arrive at the convex mirror directed towards the center of the mirror. So this time let me draw in a dashed line to the center. So if a light ray comes in like this, directed towards the center, what happens is very simple. It simply reflects off the mirror in the opposite direction. So it travels back along the same line that it came, but in the opposite direction. And that's because, remember, C, that's the center of the mirror, and this point where the light ray hits, this is just the circumference, right? So this again is just a radius. Okay, and we know that the radius is always at 90 degrees to the tangent of the circle. Okay, so that's why here the angle of incidence is 0, and so the angle of reflection is 0 as well. Let's draw another example up here. If a light ray comes along like this, again directed towards the center of the circle or sphere, it will again reflect back in the opposite direction like this. Thank you for listening.